All right, so I started showing some stuff in Excel last class, doing like a quick scatter plot. So today we're basically going to recreate some of the stuff we were doing with histograms, looking at frequency distributions. So kind of did some examples of how to do it by hand or how to think about doing it by hand. But I'll show you kind of what's more practical, especially when we have big data, is to be able to use Excel to create these histograms for us. So, we talked about with a continuous variable, we're going to have to force them into these bins, right? We can't record the frequency of every possible answer if I'm looking at income, because there's way too many possible answers. That graph's too big. So I have to do things like count the number of people who make between 0 and 30,000, right? Create these bins. So I'll show you kind of how we do this in Excel. I've got a bunch of slides down here that kind of reference what we're doing. So if you want to go back, maybe those can be helpful, but we'll kind of walk through the file together. So we've got, let's zoom in here. We had this enrollments blank file, which last class, we we're kind of looking at that vaccine percentage. We kind of did a scatter plot. So I've got this blank file. I've got a lot of stuff deleted, but there's some stuff that's still I kind of left there just to save us some time in class. And I'll kind of point out on Canvas when we're done, there is going to be a completed version of this file. So all the work we do in class, I'll put up, there's already the completed version on Canvas, but it's helpful to kind of see how we arrived at that version, right? So I've got a bunch of different worksheets down here. We're going to work with the one Indiana, right? So it's got a bunch of different Indiana universities. It has what their undergraduate enrollment is. So this variable, if I make it the title big, right, is the grand total of undergraduate enrollment. So kind of make that small so we can kind of see what we're doing here. And I'm just changing the size of that column just to kind of start out like we don't know a lot about Excel, right? When I'm between two columns and I get this kind of black line with two arrows going either way, I can just left click and then move it around to make that cell bigger. All right, so if there's words that are longer than the cell width, I can kind of hide it or make them displayed. So I think last class, I kind of showed you a little bit with cell references, right? So if I wanted to put what's in cell C2 down here, I just put an equal sign that tells Excel I need you to do something for me. If I then click on that cell where that number is, it automatically puts in with that cell reference to the cell that I clicked on. So we did a little bit of that last class. We can also use Excel to do math for us. So 10 divided by 25, right? So anytime I put this equal sign, it's telling Excel, I need you to do something for me, right? So we can have it do math. We can use these cell references, but we also have a bunch of built-in functions, right? So if I go up here next to this min, if I want to determine what the optimal bin length is, and go back, just kind of remember we had talked about it. Where is it? I had it somewhere. Oh, right here. To get that kind of optimal bin length, or the bin length that would definitely kind of cover every observation, we would take the maximum value in the data set, subtract the minimum value, and divide by the number of bins we want, right? So we need to find these things. Well, I'm going to tell you the number of bins we want to use is 6. We can change this later, and we'll see some things we can do that makes this helpful to have it in a cell. But I need to find the minimum and the maximum, right? So I put an equal sign. I tell Excel, okay, get a built-in formula. It's called min. So whenever I want to use a built-in formula, I use the name and then put a parenthesis, right? So just like any function, right? If I have y is a function of x, right, where these are some value, and I have to tell, let's say it was, I have to plug in an x value to get what y is going to be, right? So it's the same idea with Excel. These functions, you have to tell them what they need in order to compute what you want, right? So in the parentheses, we have to tell, Excel what this function needs to look through. And basically for the minimum, that's just going to be, tell it the numbers you want to find the minimum of. Well, the numbers I want to find the minimum of are over here in this column. So I can left click and select them with my mouse. Once I do that, notice it puts that range, the cell reference for that range of data. So now if I hit enter, right? So I can close the parenthesis or I can hit enter. But if I hit enter, right, it goes through all those numbers and it finds the minimum value. Okay. So we've only got 50 observations here, so it makes things easy to do, kind of using your mouse and dragging. But let's say I had a couple thousand. So like, let's say I've got all the universities over here. How can I find the minimum pretty quickly? So I'll show you, since this is a bigger data set. You know, I don't want to have to put that equal sign and drag all the way down to the 2,400 cell, right? So what's another way I could do this and save myself a little bit of time? Well, I want to move this over so we can see everything. There we go. So if I want to find the minimum, I put equals min. Instead of selecting this and dragging down with my mouse, if I select the first cell and I hold Control Shift and hit the down arrow. On a Mac, that's hold Command Shift and hit the down arrow. It'll go all the way down to the very last observation, or the cell that has the very last observation. Now, instead of scrolling all the way back up and closing the parenthesis, a nice little shortcut there. If I don't want to close the parenthesis, if I just hit enter, it'll do it for me. And now I've got that range, that cell reference for that range of data pretty quickly, right? So this is why in Excel, it's nice. I don't have to go through and do it by hand. So for larger data sets, I hit that Control Shift down arrow or Command Shift down arrow on a Mac, and it selects it pretty quickly for me, okay? Any questions on any of that before we keep moving? Shouldn't be too bad yet. Okay, so we'll go back to the Indiana data sheet. Now I need to find the max. Well, if equals min found me the minimum, probably wild guess, equal max, it's probably going to find me the maximum, right? So I'll select on that first cell, hold Control Shift, Command Shift on a Mac, hit the down arrow. It selects the whole column for me. Once again, I could scroll up and close the parenthesis, or I could just hit enter. And now I've got the minimum, the maximum, and the number of bins I want. Now it's just a matter of entering that formula that we know gives us this optimal bin length, right, into Excel. So it's just having Excel do some math for us. Say, look, okay, I want you to take the maximum value. So I just click on that value and it puts that cell reference in, and it's going to use that 72,000. Subtract the minimum value, right? Look at that difference. And then here I've got some weird goofy thing on with my Excel version. So I can't click on this last one, but I want to divide by the number of bins, which was in cell what? I3. So I3. That should give me my optimal bin length, right? 72,000. How is my optimal bin length like the same as my maximum? What did I do wrong? Yeah, right. Even in Excel, I need to make sure that I'm following order of operations, right? So I need to make sure that I'm, not just typing it in the way I'm thinking about it, but actually that mathematically it's going to do certain operations in a certain order, right? And so here I put parentheses around that difference between the maximum and minimum. Then I divide by the number of bins. Okay, now I get a number that looks a little bit more reasonable. Okay. Now you'll notice I'm going to show you how to do this kind of using that optimal bin length. But notice these values are kind of nasty. I mean, like there's no real, doesn't look like there's rhyme or reason to them. There's no like, they're not cutoffs at the 5,000s or the 10s, but that's okay. Doesn't matter what these values are, we can use them. And I'll kind of show you, if I do something a little cleaner, how it looks a little bit nicer, but we'll start out here. So I have a bunch of stuff that I left in here. I probably should have just deleted it to begin with because I want to show you how to do it. So I'm going to delete all these values real quick. Now I left my labels up here because I don't want to have to type all these out and have you wait for me. So I just have them waiting. But basically remember each bin, like the examples we did last class, 0 to 10,000, 10 to 20,000, 20, right? That's what I want to do here. Figure out the minimum and the maximum of each one of these bins. So for the very first one, right, I'm just going to start at the minimum value. Okay. So the minimum of the very first bin is just the minimum value of my data set, right? The maximum of that bin would be, well, here's my bin length. So I need to go 12,068.33 above the minimum. Or in other words, take the minimum value of the bin and just add whatever the length of the bin I want to be, or add to it the bin length of whatever that optimal bin length I want it to be was, right? So I'll just add in the bin length. Now, just like we were using the idea of 0 to 10,000 and then 10 to 20,000, the next bin always starts where the last bin left off. Now, we have to be careful with our equalities, right? Notice the equality on 12,347 is in this bin, but not in this one, right? We talked about that last class, having to be careful to make sure that no observation will be double counted. So the next bin will start off where the next one left off. Well, then we'll just have to be careful with the equalities when we're actually counting the number that fall in that bin, number of observations that fall in that bin. Okay. Everybody with me up to this point? Okay. Well, now notice, how do I find the maximum of this bin? It's the same thing I was doing before. I'm just going to take the minimum of the bin and add to it the bin length, right? I need to go that much higher above the lowest value in that bin to get the maximum value. Now, I could keep doing this process all the way down, or I could maybe copy this down and make my life a little bit easier. Now, the problem is if I try to copy these two down, because on this next one, right, this bin starts off where the next bin left off. So if I try to copy what I've done down, I start to get some issues, right? So what went wrong here? Well, every single time, right, the minimum of this bin should be the maximum of the previous bin, so it equals J7. And then when I go down one, when I copy it down one, it'll update J7 to J8. And that's right, because this bin starts off where the last bin left off, and that value would be in J8. So that looks okay. But when I copy this down, not only will I8 become I9, but I4 will become I5. So notice all the way down here, I'm starting to add in labels. Well, I didn't want to do that. I always wanted to add that optimal bin length. So I go back up here. So I'm going to delete this because it's wrong. I'll go back up here. And, okay, I want I8, that cell reference, to keep updating, but I don't want my bin length cell reference I4 to. So how can I prevent this from happening? I think I showed you guys a little bit of how to do this last class. But anytime I put $ in front of my cell reference, it does not change when I copy it. It freezes that cell reference. Okay? Now, I think the other shortcut I hopefully mentioned, if I didn't, if I highlight what I want to put $ around, and this will become a little bit clear why this shortcut is helpful in a little bit. But if I hold Command T on a Mac, or the F4 key, if you don't have a Mac, or on some laptops, you have to hold an FN key and F4, it automatically puts those $ in there for you. Okay. So now when I copy it down, I get all the way down here, oh yeah, it's taking the minimum of the bin and it's adding the bin length. Okay. But I didn't have to enter it in for every single bin. Kind of save me some time using those cell references and being able to kind of exploit the fact that they'll update when I copy them. Any questions on any of that? So we're going to jump into something that's a little bit more difficult. Yeah.
Can you tell us again how that number turns to be 6?
I just chose that.
Oh.
So that's one of those things that we choose, whoever's working on the data, you would choose how many you want. So nice thing is, that's a good question. What if I had done 10? Well, notice if I put this in here as 10 instead of 6, it updates my optimal bin length. It starts to update these. Now, the problem is we've done it for 6. Now we're going to have to go down to make sure we have 10 bins instead of 6, right? I'll have to copy this down to make sure I have 10 bins. And I'd have to change my labels. There's no real easy way to make the labels update, or at least not that we're going to look into in this class. Any other questions? A good question. I just hit Control Z there to go back to 6 bins. Okay with that? Okay. So now we know what our bins are. Well, remember, ultimately we want to get a frequency distribution. So I need the frequency of observations that fall in each one of those bins. I could count these up by hand, right? Go through the data and look at the number of schools that have undergraduates in between 279 and 12,347. But, in this Indiana data set, I've got 50. Maybe I could do that by hand. I don't want to do that if I was trying to do this for, now this thing's in my way. Oh boy, there we go. I don't want to have to do that if I was using the entire country's, university data set. I don't want to do this by hand, right? So go back to Indiana. How can I find these frequencies no matter what the size of my data set? So there's a built-in formula in Excel called Countifs, okay? So what Countifs is going to do is it's going to look through data and it's going to count an observation only if certain things that you tell Excel are true. So for us, we want to go through the data and count the number of observations that are greater than or equal to 279, but that they're also less than 12,347.3. So that's what we want to do, and that's what this function will do for us. But we need to tell it 4 things, right? First of all, we have 2 criteria. 1, that it's greater than or equal to 279. 2, that it's less than 12,347. The other 2 things we need to tell it is basically what range of data are we looking through. So I'll kind of start to walk you through this. So first thing we do is, where's the range of data I want to check to see if this certain criteria is true for? Well, that's just over here. So I can select the first cell, Control Shift or Command Shift on a Mac, hit the down arrow, scroll back up, and you can kind of see if I move this, it put that range of data, those cell references in for me. Anytime you have to tell Excel multiple things, you need to separate them with a comma. So we told it the range of data to look through, comma. The second thing, and notice it kind of tries to bold this and let you know, what's the first criteria you want to check? Well, the first one is it greater than or equal to 279? So the syntax in Excel is whatever you want, whatever kind of equality operators you're using. So here we have greater than or equal to, and you type it just like you say it. So if it's greater than, it would just be a greater than sign. If it's greater than or equal to, greater than and an equal to sign. But you have to put whatever that equivalency operator is within parentheses, right? So I had to put, not parentheses, quotation marks around it, right? So once we do that, the next thing we're gonna do, and this is just good practice. You wouldn't always need to do this if you were typing the number instead of like using a cell reference. But if we do it this way, it'll never have an error or never have an issue. So I always teach it this way. The next thing is put in an and sign. This just has to do with the syntax of the way that this built-in function is like coded in Excel, okay? And then what are we checking to see? Is it greater than or equal to that 279? But instead of typing the number in, I'm going to click on the cell that value's in. That way, if something ever changed, it would automatically update. I wouldn't have to go back in and like retype like, oh no, I'm not using the minimum of 279 now, I'm using some other value, right? So it'll automatically update it when we're kind of using cell references. So that's the first thing I want to check. So the next thing I have to tell it, comma, the third thing is, okay, I checked to see if the data was greater than or equal to 279. I counted those up. Now the next thing I want to do is count it only if it's less than 12,000. So I need to tell it, go back through the data again. So I need to like select that entire column again. So instead of selecting it by using, Control Shift and hitting the down arrow, I'm going to scroll over so you can see this a little better in a second. What I'm actually going to do, instead of selecting it, because I can see here what the range I need to look through again is, I'm just going to type that out. And I only do that because if I had a larger data set, when I select the column, it sends me to the bottom. I have to scroll all the way back up. Just a little bit easier to type it in that second time since you now know what it is, okay? And then what's the second criteria that I want to check? Well, now I want to see, is it less than? So I put that in those quotation marks. Use the and sign. That's just the syntax Excel needs. And is it less than the maximum of that bin, okay? And I'll close the parenthesis there. So range of data you want Excel to look through, comma, first criteria you want to make sure is true, comma, tell it the range of data again, comma, what's the second criteria you want to check. Okay. Now, each time we do this for a bin, the criteria is going to be the same, right? It's just now I want to check to see, is it greater than or equal to 12,347, and is it less than 24,415, okay? So I want to keep doing the same checks, but I just want the values to update when I'm doing this for the next couple bins. So if I copy this down, is that going to work? So I7 and J7, if I copy it down one cell, become I8 and J8. So yeah, that's good. But what's going to happen as well is this range of data is going to update. So notice if I left click, see when my mouse becomes like this bolded plus sign, if I left click and kind of like drag this down, it copies the cell. So it might look like, oh, this is working, but notice when I get down here, my range of data now starts in cell C7, right? Because it was updating those cell references as well. So I don't want that to happen. So I'm going to delete this because I know it's wrong now. If I want to copy this down, I want to allow the minimum and the maximum of each bin to update, but not the range of data cell references. So how can I stop that? Yeah, F4, Command T. So I'm going to select that. F4, select this. F4, put my cell references, those cell references are now frozen. Now, if I copy this down, notice these don't change, but it does use kind of update those minimum and maximum of each bin. Yeah. You probably have a comma in the wrong place or not enough commas. So between each one of those things, notice range of data, comma, then what the first criteria is. Command T should put the dollar signs in there for it. Yep. Did that fix it? Did you figure it out or no? No. So too many arguments means right here we have like 4. Maybe if you would have put like a comma at the end or something as well. Might get mad. I might not like that. So if we're ever working on things and you do like fall behind and we can't quite get it worked out, always make sure you, if it was me, I would then go check that completed version, right? Because if it's hard to see on the screen or something, you could also have the completed version open just to like double check, okay, what, match it up, see what exactly do I have that's maybe a little off. And that's a frustrating thing about Excel, right? It's a frustrating thing about any coding or any data, program, is they all have like their own syntax on things. And like, let's say I like forgot this quotation mark, right? I get an error, but everything was right except for one little thing, right? And if I change that one little thing, oh, come on. Oh, what did it do? It tried to add in a bunch of stuff over here for me automatically. Yeah, right. But if I get it, excuse me, if I have that quotation mark there, everything works fine. So that is a frustrating thing. There's no way around that, right? There's something in life that are frustrating. So we've got this working correctly, except for one exception. With one exception. Notice in this last bin, shouldn't my maximum value being recorded? But one thing that's a little bit unique is if I set it up with the equality on the lower end, in order to capture that maximum observation, notice there's an equality on the upper end of this last bin, right? So I'm going to go in here and I have to make sure that for the last bin, is it less than or equal to that maximum value of the bin, okay? But once I change that, now it should be capturing that maximum observation. Okay. Any questions on that before we keep moving? Yeah.
Go back up to the equation on 23.
This one?
Yeah.
Any other questions? Okay. So we'll walk through this one more time because I'm going to show you, here's how we use the optimal bin length, right? That 12,000. But to me, it looks like the majority of these schools are kind of smaller. So like maybe I want to choose a slightly lower bin so I can get an idea about what the distribution looks like on the lower end a little bit better. And so I'm going to use 7,500 instead of 12,000. So I did the exact same setup here, right? To find the minimum and the maximum of each bin. I literally just reproduced what I had over there. So I'm not going to go through that again, but you just take the minimum of the bin and add the bin length, right? And that way I've got my minimum maximum of each bin. Now, if I choose a bin that's smaller than what that formula told me, notice if I only use 6 bins, I'm not going to get up to the highest value. So in this last bin, I have to create this catch-all, right? Does the school have 37,000 or greater, or 37,500 or greater? So what I'm going to do there is, in order to use that Countifs formula, greater basically would just mean going to infinity. So I'm just going to choose a really, really big number, right? Like something I know that no school is going to have enrollments that high, right? So what did I choose here? 1 million, right? So basically, it's kind of like saying, is it greater than or equal to 37,500? Just going off to infinity. I didn't put infinity in here, but I put a number that was really, really large, right? So maybe in practice isn't like the perfect way to do it, but for the sake of, if you have any idea about what the context of your example is, you'll know you can set a maximum value that's high enough, right? So we can do the frequencies, same idea, Countifs, right? So I'm going to use that Countifs function. First thing, the range of data. So I'm going to go over here, select the first cell, Control Shift, Command Shift on a Mac, hold it, hit the down arrow. And then I'm going to go over so you can see what I'm doing. Now, one thing, if you don't want to like scroll back up, you can always keep typing things up here in this formula bar. I just don't use that when I'm showing you how to do it because it's really small and you can't make the view on it a whole lot bigger. So I just think it's easier to be able to, I'll scroll back so we can see it. So there's the range I want it to look through, comma. What's the first criteria? Is it greater than or equal to? Put that in quotation marks. Use the and sign. Is it greater than or equal to? Well, now we're going to start at 0. Okay, just to make it look a little cleaner. Comma, look back through the data. Well, I now know what that range of data reference is. So C2, whoops, and then colon C51. So that go through C2 all the way to C51. Comma, what's the second criteria? Basically, is it less than 7,500? Right? So less than in quotation marks, and sign, select where that maximum bin value is at. Okay. Any questions there if we keep moving? It's basically the same setup we had in the last one. I'm just using a different bin length. So I cheated a little bit with my labels because technically with enrollment data, this isn't technically continuous, right? Because I can't have half a person enrolled. And so I'm treating it as though it's continuous because it is such a wide range of values. And this is actually a good example where we could also create bins for discrete data if it was a large enough number of discrete values that we could see, right? So same process would occur, but that's why I could cheat a little with my labels because I know if it's less than 7,500, the only first possible number that meets that would be 7,499 because I can't have half a person. So I cheated a little bit with my labels. I didn't cheat. I just, I didn't write them out as nicely as I did in the other example. So I'll close that. Same thing. When I want to copy this down, I want those minimum and maximum values to change, but I don't want the range of data to change. So I'll select that, Command T on a Mac or F4, put those dollar signs in there. Now when I copy it down, the range of data won't change. Right? Oh, what did I do wrong here? Oh, what sign did I use? I want greater than here, right? Greater than or equal to 0, right? Nothing's going to be less than 0. So I had this this sign incorrect, right? It should be greater than or equal to. Now when I copy this down, we get something that looks a little more interesting than what we had with the quote unquote optimal bin length for when we use the formula. And our labels look a little bit cleaner as well. If I wanted to type these out like I did on the other one, right, with the less than or equal to and the less than signs here, these would look a lot cleaner when my cutoffs are like at every 7,500. Right? So now I've got my frequencies. So at this point, I can create my histogram. All a histogram is a bar chart of that we're creating, but using bins, right? The histogram just means we took continuous data, but we kind of forced it down to be in one of these 6 bins. So if I select my labels, just left clicking on them, hold Control and select my frequencies. Then I go up here to insert. We've got all of our chart options. Just go up here to these column charts, right? And that's basically, we could do 2D, we could do 3D. That's basically my histogram. Shows me that the distribution of the data that most schools have less than 7,500 enrollment. And then there's a few that are larger and there's a couple that are really large. Right? It's not the most interesting distribution, but you can imagine with a different variable, we might get something that looks a little bit more interesting. But this, the data is what it is. Okay. So that's how you would create a histogram. When it comes to like that first Excel assignment, I'll probably assign that on Monday after we're done with class. I don't care if you have like a pretty graph. Like if you wanted to stop at this point, I'd give you credit because you've got the labels, you've got the frequencies. Like I don't care if you've got the prettiest chart in the world or you're adding fancy titles to it. I just want to see that you can get the data into that visualization, right? Or into this graph. Okay. Any questions up to this point? I'm gonna get rid of that for right now. We're okay with everything so far? All right. So at this point, we might not remember this from last class. If I were to add up all these frequencies, what should I get? You don't have to necessarily give me a number, but what would that represent? No? Did you? No one? So when I did that count ifs, if I've created my bins correctly, we said one of the rules is they have to be exhaustive. Every observation should have been counted in at least one bin. So if I add the frequencies up, it's going to add up every single observation. So when I add those frequencies up, I should get my total number of observations, right? There's 38 universities that are in this range, 5 in this range, 3 here, 1 here, 2 here, 1 here. If I add those universities up, that should be every single university I had in my data set, right? So I'm going to use this sum function. Basically, the sum function in Excel just adds up the numbers that you select. So I'm going to select these frequencies. Oops. Within the sum function, it should just add them all up. That should be the total number of observations I have. Okay. Now, if I look at this, my data starts in cell 2, ends in cell 51. So I do have 50 observations. Now, if I don't want to have to scroll all the way down or count them by hand, another way I can check, like kind of check myself here. So if I add up my frequencies, it should be my total number of observations if I haven't made any mistakes. So one way I can check that is to get the number of observations. If I use this count function, so equals count, and then I select a bunch of values, it just counts the number of cells that have values in them. So I'll go over here, select my very first observation, Control Shift or Command Shift on a Mac, hit the down arrow. Now it's put that into that count function. I hit enter instead of scrolling up to close a parenthesis just to make it easier. And I can see that count function says there's 50 observations as well, right? And kind of the nice thing about that count function is, so I'll go back over to this all data set that's really big, 2,000 some observations. So right here, I'll just show you, if I was to use the count function here, and I wanted to count how many universities I have across all states, I'll select the first cell, Control Shift, Command Shift on a Mac, hit the down arrow, goes all the way to the very last school. I'll hit enter, sends me back up, and it says, oh, there's 2,466. So I just counted a pretty big data set very quickly, right? That was a lot louder than I meant it to be on that snap, but real quick, makes working with big data a lot easier when you can use Excel. Okay. All right. Any other questions before we keep moving here? Got an Excel packed day. Well, I don't know if we'll get too much after, but we're getting close here. So you can't quite see this title, so I'm going to make this cell a little bigger. But what if I wanted to figure out what my relative frequencies are? You remember, how do we turn frequencies into relative frequencies? We simply divide by the total number of observations. Well, do I have that? Yeah, that's what we were just talking about, right? So I'll go up here, put an equal sign. I want to take this frequency, right? I don't have to type a number in, I don't have to punch it into a calculator, just click on the number, divide it by total number of observations that I had down here. If I hit enter, comes up with that relative frequency for me. Now, if I want to copy this down, all right, so I'm just dragging this down to copy it, I start to get errors. Why am I getting errors? Oh, because my denominator, I always wanted to be the number of observations, right? I wanted, you know, for each bin, I want to make sure I'm using the frequency of that bin. So I wanted that cell reference to update. But when I'm dividing by the total number of observations, I don't want that to ever change. I should be doing that every single time. So I'm going to go back up here. Okay, this total number of observations cell reference, I want to freeze that. So I'm going to F4, Command T on a Mac, I'm going to freeze that cell reference. Now when I copy this down, when I get to the last bin, okay, it's updated to use the frequency of this bin, but it hasn't changed the total number of observations because it should always be dividing by that. Yeah.
Can you explain the dollar signs with the F4?
Yep. So I'm going to get rid of these here. If you highlight the cell reference that you want to put dollar signs around and you hold, so if you might have an FN key, so like it's the function key, because your F keys are like multiple functions. If you have that FN key, hold the FN key and then hit F4 and it should put the dollar signs in front of the references for you. If not, you might have, there's another type of key. It's the same idea as an FN key, but it basically toggles certain keys between two functions. I can help you after class to figure out exactly what it is. But for the most part, I mean, things like this, it's also not that hard to just put your $2 signs in there. With the longer stuff, it does save you, makes it a little bit easier and saves some time. Yeah, I can help you figure it out after class. Like I said, some laptops are tricky. There's just a key you have to hold to unlock the power of other keys or the second function of other keys. Any other questions? Okay. So we've got our relative frequencies. If I was to use the sum function and add up those relative frequencies, what should those add up to? 1, right? We kind of talked about that last class. Sure enough, you know, so at this point, if you're using, or you're doing the Excel homework and you add your relative frequencies up and you don't get 1, you know you made a mistake somewhere, right? But that's like kind of a good check you can do along the way. If I want to do percent relative frequencies, what's the only other thing I need to do? Yeah, I've got my relative frequency, so I just click on that, and then I multiply it by 100. All right, just turning it into a percentage. Now, when I copy this down, it updates the, you know, to each whatever bin I'm looking at, updates it to its relative frequency. So now I've got my percent relative frequencies. So at this point, I could do things like, maybe I want to put these percentages. I'm going to go, so I'm going to select these. Actually, I'm going to select my labels first. Hold Control, or probably on a Mac, hold Command, and then select my percent frequencies. I'll go up here to Insert, and I'm going to do a pie chart. Okay. Do a quick pie chart. You can kind of see which color lines up with which bin. All right. Pretty easy to do. I could, well, here's my labels. Hold Control, select the relative frequencies. Go to Insert. I could insert one of these kind of column vertical bar graphs. Here's my histogram, right? Using this new bin length. I could do that's pretty easy. The other thing I want to kind of point out though is when on that Excel, I'll make it obvious in the way that it's worded, but on that first Excel assignment I give out Monday, if I ask you to do a histogram, what I don't want you to do for that first assignment, and I will mention it in the assignment, what I don't want you to do is use this built-in graph that's called statistics chart, and then here's a histogram, right? Now, you can kind of see here, I mean, it's harder to get it to work. So if I want to select, if I select the entire data set, and then I go to Insert, and then a histogram, it basically creates that histogram for me, okay? Now, the issue is I might give you some specific range, not just the optimal range using that formula. And you can play around with the options in this to like change what the bin length, and you can kind of make a catch-all category. It's a lot harder to do. Out of all the semesters I've had this, I've only ever had one person after I told them in class and on the assignment not to use the built-in tool. I've only had one person who, if they decided to use it, actually used it right. So if you use it, you're probably going to lose a lot of points because you won't be able to use it correctly because I haven't walked through and shown you how. And it's honestly not, I mean, it's a nice quick snapshot look at what the distribution will look like. But I want you to do it the way that I've set up here, where you kind of create the minimum and the maximum of each bin, create the labels, because there's a lot of things involved in that process. So using the Countifs formula, using the min, the max, things I want you to start getting used to. I know we're going to use the Countifs formula a couple other times this semester. So I want you to show me you can use it early on and get used to using it early on. Also, like I said, when I'm giving you specific cutoffs and specific numbers of bins, it's a little bit trickier to use that built-in histogram tool just by selecting the data. So make sure you have a table where I can see the frequencies, and then from those frequencies, you create your bar graph, your histogram. Is it clear what I'm saying there? Anybody have any questions on that? Okay. So, I mean, we got quite a bit done here. We got relative frequencies, we got percent relative frequencies. I think I'm going to hold off on doing cumulative frequencies until Monday. So after Monday's class, I will splice anything that we've done in Excel. So the scatter plot stuff, everything from today, and then whatever's on Monday, and I'll kind of throw it into one video file. So you'll have like an Excel like template help video, so to speak, up on YouTube. But because the discussion has kind of went across multiple classes, I'm going to have to kind of splice that together after Monday's class. So I'm not going to let you out quite yet. A little bit more before we get out of here. Let's scroll down here. Blah, 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 blah. So we did scatter plots last class. One other thing we can do in Excel. I'll play around with this from here. So let's say we got time series data, right? So here I have the US unemployment rate for the last however many years. I might want to put this in a graph, right? So basically, if you have time series data in Excel, you can just select the data and insert a line graph, and you can get a nice histogram. So if I were to just say, oh, not do that, copy and paste this, won't make it look pretty. All right, so I had this data, right, the unemployment rate over time. You might think that I could select the year and select the variable, go to insert, just go to my line graph. But notice it tries to plot them as two separate variables, right? It's not using this year as my X variable, which is kind of what I want. So anytime I have time series data, I'm going to select the variable, insert a line graph. And now it kind of shows me what's been happening to the unemployment rate over this time frame, but I don't have my years down. So how can I add my years in? If I left click on these numbers, kind of puts this box around here. I then right click and go to select data. Now my axis labels, right now they're 1 through 10, but what I want them to be is the years. So I'll go to edit. It wants me to select the range where the labels are, and the labels are right here. They're my years. I hit OK. Now it's showing them as years. I hit OK. Now I can start to tell stories. All right, once I have a time series graph, I can start to interpret the data. Unemployment was kind of pretty stable or decreasing, in the mid 2000s, had a pretty dramatic increase in the late 2000s, peaked kind of around 2010, and has kind of slowly kind of fallen off up to 2014 since then, right? So time series graphs are really helpful because I can, like I said, I just told you a story about over this whole time frame about what's happening to this one variable, right? That's simply from a picture. I don't see the numbers. Even if you took the numbers off the y-axis, right? I could still tell you that story. Okay. Now you can graph multiple things. So let's say I had like Canada's unemployment rate over here. I don't know what it would be, 4.3. I'm just making up numbers. I have no idea what Canada's unemployment rate was relative to ours during this time period. So I'm going to delete this. If I wanted to say I'll call this the United States. So that's their unemployment rate. And here was Canada's unemployment rate. If I select these two labels and then all the data here, then I go to insert this line graph, it'll plot both of them. So now I can kind of tell you a story about the US unemployment rate relative to Canada's over this time frame. And I have to go back in, left click on the numbers, right click, select data, go to my axis labels, and then once again, select the years because I created this new graph. But once I do that, now I've got this nice time series graph, and I can put as many countries really as I wanted to up here. All right. I went through that a little quick. Are there any questions on anything I did there to? Okay with that? Okay, so these distributions are really kind of the start of how we want to start thinking about variables. So we just did, we did it for, technically you could consider it a discrete variable, but the same thing would apply for a continuous variable as well. That will be what the first Excel assignment looks like. We'll talk about cumulative frequencies on Monday, and then kind of dive into the next topic, which is calculating like means and averages and variances. Okay. So what do you have to have done before Monday though? All right, the 2 Learn Smarts. So you should be registered for Connect, and then and I'll start using iClickers on Monday as well. So make sure you've got your iClickers registered. If you've done Reef, you shouldn't need to like register a number. It should just sync it up when I'm running the program. Okay. All right. Have a good weekend. I'll see you guys on Monday.
It was FN.
You did find it? Okay.
Yeah.
Well, because some of them, it's a lot smaller and they kind of hide it somewhere, but usually like all these keys have multiple functions. So
Okay, I was gonna ask you too about the Learn Smarts.
yeah.
Can you explain those for me? Because I got the Connect registration.
Okay.
Is that the same?
It's on the same thing. So if you go to Canvas, there
Yeah.
should already be those 2 Learn Smart assignments. If you click on it, if you've already registered,
Yeah.
then it'll send you right to the courses. It'll send you right to the assignment actually. And basically just asks you questions, kind of walks you through. Okay.
Yeah, like you see the screen and then go to reading and then go to question. I was just gonna ask you, is it usually 2 a week or is it like?
No. That was just kind of start us off.
Okay.
I think different chapters will progress through quicker. So the Learn Smarts are not going to be as regimented in terms of when they're assigned because it's just
Yeah.
some chapters we spend more time on than others.
Okay.
So those
Yep.
are
Thank you.
considered the Learn
Have a good weekend.
Smarts.
Okay, so if you hit launch.
That's what I'm really familiar with Connect, but the Learn Smart.
Yeah, and then if you begin. it should matter.
Oh, that is.
Yeah.
Okay. That's what.
Yeah.
I
Yeah,
didn't know if there was
sometimes it won't
a-
automatically launch. Once you hit that launch, it should send you right to the thing,
Okay.
right to the assignment.
No, that's great. I didn't know, just because I didn't know if there was a difference between like the Connect assignments and Learn Smart. If it was just-
There is, yeah. The Learn Smart should be a lot easier, take you 10 minutes. It doesn't matter if you get the questions right or wrong, like it's just for completion.
Yeah.
And the Connect is more like captive right answer, hit the points.
Okay.
Yeah, and they're a little bit longer, a little more difficult.
Okay.
I just want to tell you, you should
Thank
have gotten an email from Disability Services.
Okay, I did. I didn't even
Yeah,
look at the name yet, but,
it's from me.
okay.
I basically just get alternate testing locations
Okay.
and I get time and a half on tests. So,
Okay, so usually you go to the rooms they have,
Yes, and,
or is there a room that you've used in the building?
well, you have two, right? Have you done them?
Yeah, the learning center.
Yeah, I just couldn't.
Okay.
go.
Yeah, I'll usually just email, they'll contact me and I'll email them the exam earlier in the week. If you do want to use a different location. If you want to stay in the building, like usually there's a room I can reserve, and at this time I think, I could check either way. It doesn't, yeah, if you don't mind going there, then I'll just send it to them.
Yeah, because I don't have, the next class I have is at 1 PM.
Oh, okay, so
So-
it shouldn't-
It shouldn't interfere, but I just wanted to let you know.
okay, I appreciate it.
Yep,
Yeah. Have a good weekend.
thank you.
The last formula won't grab. That's
Last
what it is.
formula?
Yeah, like the last thing I put in, it won't, you know how it highlights it, if it's in there, it just stays black. That's what it is. I might come to your office hours next week.
Okay, yeah. We should, yeah, we need to figure it out.
Cause I know Excel and I was sitting there clicking it, it wasn't working. So I was like, and then I noticed that everything else was highlighted except for that last thing, like I7 or whatever it was.
Did you maybe hit 1 or like L or something?
I clicked it, like I clicked.
Oh.
formed the cell, so I don't know what it's doing.
Okay,
But because I didn't have any trouble with the second one,
okay,
that we did the second.
Countifs,
frequency that we
yeah,
did,
yeah, yeah.
But the first one would not let me.
okay, yeah, we want to figure out what the error was, but yeah, I'm glad the other one worked.
Have a good one, thank
You too, have a good weekend.